In this video, we're finally going to get a way to straight up solve quadratic equations that are in standard form, and we're going to do that by using the quadratic formula, which you see written there in front of you, negative b plus or minus the square root of b squared minus 4ac all over 2a. And despite Sweet's reaction there, you will have plenty of time to do this. It just takes practice and it takes some care. Don't get intimidated by this. You are going to be asked to memorize it. However, there will be several things to help you along with that, and it just takes some practice. If you're working the exercises and you're writing down this formula at the beginning of each exercise, you'll kind of have it memorized without even meaning to by the time it's all done. So don't panic, don't wig out over the look of this thing. You'll be fine as long as you do the work like you need to. So the quadratic formula, why we would bother using this thing that looks so crazy complicated, is that it will always, without fail, give you all the answers, all the solutions, all the zeros, x-intercepts, roots, all of those for a quadratic equation in standard form. We know how to solve them in vertex form, we know how to solve them in intercept form. This formula will allow us to solve them from standard form, and it's always the same. You never do anything different on this, so it's very easy to apply. You just have to know the formula and be careful as you do the work. So let's look at this formula a little bit, look at some of the details. First of all, you may recognize this part inside the radical, this b squared minus 4ac. We just talked about that part. That part is called the discriminant. And so everything you just learned about how to use the discriminant to find the number of solutions still applies. We can take this b squared minus 4ac, which is just part of the quadratic formula, and use it to determine the number of solutions. Hopefully now this actually makes the discriminant make a little bit more sense. When the discriminant is positive, we're taking the square root of a positive number, which is going to give us 2 real answers. When the discriminant is 0, we're taking the square root of 0, which is just 0, which will give us 1 answer. And when we try and take the square root of a negative, we're going to end up with no real solutions. Now the other part of this formula that I want to point out to you so that you notice it and recognize that it matters is this plus minus symbol. What this really means is that this formula is 2 formulas in one. So in one of these we would take x equals negative b plus the square root of b squared minus 4ac, all of that over 2a, and that's going to give me one of my roots, x equals that. So notice that one just takes the plus sign, and over here I would have a second equation, negative b minus the square root of b squared minus 4ac, all of that over 2a. And so this is how it gives us both solutions. We do it once, adding these two, and then we do it again, subtracting those two. So really the only way to get the hang of this is to see the thing in action. Remember that when we are solving these, we always have to have the equation itself set equal to 0, and then we need to find a, b, and c. So let's go ahead and find those. A is the coefficient of x squared, so in this case it's 2. B is the coefficient of x, in this case negative 3. And c is the constant term, which is negative 9. Now, every time you work one of these, I want you to start by writing down the quadratic formula in its entirety. This includes when you're practicing this on IXL, I want you to have a sheet of paper out, and I want you to copy down this formula and substitute into it each time. This has a number of benefits. First, it'll help you memorize the formula a lot faster. Second, if you are writing this down, that is something you do not have to hold in your head. You don't have to try and memorize where all these numbers are going because it's written down. That's going to help you perform these calculations a lot more accurately because you're saving your brain power for doing the hard parts of it, not just memorizing where things go. So once you've written it down, then what I want you to do is to substitute in all of these values. And when you do that, for this b, substitute that in parentheses because notice now we have minus a negative, which is going to make that positive, plus or minus the square root of, and again with the parentheses, negative 3 squared minus 4 times a, which is 2, and c, which is negative 9. All of that divided by 2 times a, which would be 2 times 2. Now from here, do not, I repeat, do not try to plug this all in the calculator all in one go. The odds of you messing something up typing this in are very, very great. And I don't just mean you as a student. I mean any human being trying to type this into a calculator properly is very, very apt to make a mistake. So before we do any of that, let's just simplify each area. So first, start with this one. Negative 3 would be positive 3. Plus or minus the square root of, and this part, we can simplify that pretty straightforward if we just go piece by piece. Negative 3 squared is positive 9. Minus 4 times 2 times negative 9. Ooh, forgot a parentheses there. So I take negative 4 times 2, which is negative 8. Negative 8 times negative 9 is positive 72. All of that over 2 times 2, which is 4. So notice that I took an extra step and simplified. But let's keep that trend up. Over here I'm going to say x equals 3 plus or minus the square root of, and I can do 9 plus 72. 9 plus 72 is 81. All of that over 4. Now, once you get to this point right here, what I want you to do is to check and see if that square root can be simplified or comes out as an integer. So in this case, first thing I would do is plug the square root of 81 into a calculator and see if it comes out nice and neat. If it comes out as a rational number, that's fantastic. We can just use that. So in this case, it does. The square root of 89 is just 9. So I would say 3 plus or minus 9 over 4. Now, once I'm to this point, what I need to do is separate this off into two problems. The first one, I'm going to say x equals 3 plus 9 over 4. And for the second one, I'm going to say x equals 3 minus 9 over 4. So 3 plus 9 is 12. 12 divided by 4 is 3. So one of my solutions is x equals 3. The other one, 3 minus 9, would be negative 6 over 4. And you can simplify that down to a decimal, which is negative 1.5, or leave it as a fraction. Either one is okay. But those are my two solutions, x equals 3 and x equals negative 1.5. Now again, this process is long and complicated, but only in its whole. Each individual piece is actually pretty simple. It's just a matter of applying them all correctly. So let's look at another. Example 2, I've got my quadratic equation. It's set equal to 0. I have to check for that each time. That's good. So let's find my values. A is 7, B is negative 12, and C is negative 18. So what I'm going to do now is I'm going to write first the quadratic equation in all its glory. Remember, I'm writing this down each time to help me memorize it. For AC all over 2A. And then the next thing I want to do is substitute in those values using parentheses. Notice again I have that negative, a negative, plus or minus the square root of b is negative 12 squared minus 4 times 7 times negative 18, all of that over 2 times 7. And then, just as I did before, what I'm going to do is just go through and work each one of these areas before I ever try and plug this into a calculator. Negative negative 12 is positive 12. Plus or minus the square root of negative 12 squared is positive 144. Negative 4 times 7 times negative 18 is a great problem for a calculator, and so I will run that through a calculator, and I get 504. So I'd say plus 504. Negative times a negative is positive 504. And then all of that over, well, that was ungood, wasn't it? Let me try that line again. All of that over 2 times 7. Now I can simplify this down further. I get x equals 12 plus or minus the square root of, well, 144 plus 504 would be, let's see, 8, 4, and a 6. So 648 divided by 14. Now, once I've reached this point, I'm going to put in the square root of 648 and hope that it comes out to a decimal. What I can tell you is that it does not in this case. And so what you're going to have to do is you're going to have to simplify 648. Now, in order to save you some time, I've already worked out the prime factorization of this. And so I can go ahead and tell you that 648 is going to be 2 times 2 times 2 times 3 times 3 times 3 times 3. And that whole process, hopefully you remember.
Students, Painful Punch is now meeting in the balcony of the auditorium.
All of this over 14. And what you'll recall is that we take any groups of 2 that we have, and you're going to move those to the outside so that we get x equals 12 plus or minus 2 times 3 times 3 would be 18 root 2 over 14. Now this can be simplified a little bit in that I can simplify the fractions on this. However, that's not the point of what we're doing here. And 18 times the square root of 2, you can enter that into a calculator and it's still going to be irrational, which means I can actually leave my answer just like that. I don't have to simplify that any further. I can enter 12 plus 18 root 2 over 14 into a calculator and get a decimal. Rounded off to the hundredths place is just fine, but it's also perfectly acceptable to leave your answer like that, particularly if you're writing out an answer. IXL is going to ask you to round so that the computer can check, but that right there is a perfectly acceptable answer to give to another human. All right, let's check another example. In this example, we do pretty much the exact same thing that we've done all the other times. So we're going to take A, which is 5, B, which is negative 3, easy for me to write, and C, which is 1, and we're going to substitute that in to the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. Substitute our values in, so I get negative 3 plus or minus the square root of negative 3 squared minus 4 times 5 times 1. All of that over 2 times 5. Now simplify each area to make this ready to put into a calculator. Negative 3 would be positive 3 plus or minus the square root of negative 3 squared is 9. Negative 4 times 5 times 1 would be minus 20, all over 2 times 5, which is 10. Simplify inside the radical, and we find something that should stop us right in our tracks. 9 minus 20 is negative 11. When we take the square root of a negative number, what we're going to get are imaginary solutions. So once I get to this point and I see that the discriminant, the value underneath the radical symbol, is negative, I can just go ahead and stop and say, hey, no real solutions to this guy. Don't even have to work the rest. So keep your eyes open for that discriminant. If it comes out negative, know that you're done right there and then. Last example to look at is going to be a situation in when A, B, and C are not nearly as clear-cut. So for instance, in this problem, you can see that I have the thing not equal to 0, which should set off alarms immediately. So rather than try and work this as is, let's take this thing and set it equal to 0. So that gives me 4x squared minus 64 equals 0. Now I can use my quadratic formula. I just need to know A, which is 4, and B, which is the coefficient of x. And notice the x term is just straight up missing in this problem. When that is the case, then B is going to be equal to 0. And C in this case is, of course, negative 64. So what I do is the same thing I do every time. And I just had to resist an urge to call you Pinky right there. B squared minus 4AC over 2A. Notice again, I'm taking the time to write that down every single time. B is going to be negative 0, which sounds conspicuously like 0. And then 0 squared, which again sounds a whole awful lot like 0, minus 4 times negative 64. All of that over 2 times A, which is 4. So now simplify each area. 0 is unnecessary. I don't have to write that part down. So I just get plus or minus the square root of, again, this 0, unnecessary. 0 means nothing. I can safely leave it out of the equation. Negative 4 times negative 64 gives me 1024 over 8. And now what I do is I take this 1024 and I enter it into a calculator and see if it comes out even, and I believe it does. I suspect it is 32, but I want to verify that. Square root of 1024 is in fact 32. So over here I can just go ahead and say that x equals plus or minus the square root, not square root, we took the square root, so it is plus or minus 32 over 8. So that leaves me with two possibilities. I could have x be positive 32 over 8, which you might recognize as 4, or x could be negative 32 over 8, which is negative 4. And so I have my two solutions there and there. So for these, when it's not equal to 0, we have to do a little bit of algebra to have it set equal to 0. And if the x term is missing, that means b is 0. If we had something where it was 4x squared minus, say, 8x, and the c term was missing, that would mean c was 0. If you have a variable there and like it's written there, but there's no coefficient, you can assume the coefficient is 1. All right, finally, to recap of the longest video of the year, the quadratic formula solves anything in standard form. It works every single time as long as it's set equal to 0. The discriminant, which is the part underneath the radical, will tell us the number of roots. Go slow. Be careful. Write everything down. Do not try and do these in your head. Do not try and do these on the calculator. Write everything down. And remember those rules we talked about for when the coefficient gets funny. Practice hard, but go slow. Build accuracy first, speed later. You'll get this. Good luck.